Yeah, as I told you, this is supervised learning, and then the prediction, that is predict the probability of the target value. Here, dependent variable dichotomous, that is what you people statisticians will call dichotomous, and possibilities, only two possibilities of class, that is 0 and 1. Just now I showed you the PPT, but at the same time I have some that is here types of logistic regression. Means here we have two or more categories. Based on these number of categories, logistic regression can be divided into binary, that is called it as a binomial, okay, yes or no, true or false, multinomial, that is type A, type B, type C. Here for example, variable may represent a type A, type C, good, bad, and medium, large, small, like that. Ordinal, see here, more than one, that is two. Ordinal is having, as you know, rating good, very good, excellent, the scores like 0, 1, 2, 3, 4, 5 we have. But here in our example, I'll have a binary logistic regressions that I'm performing. Okay, now what happens, as already I told you, that is in here I'm using my MATLAB for plotting, NumPy. Okay, that is for mathematics. Here I am using see here linear model, that is linear model. In that I am using what, logistic regression function. I am importing from the library sklearn.linear model. In the linear model I have one more regression, that is called it as a logistic regression, that I am importing from sklearn library. Apart from that, I am also importing classification report and also the confusion matrix. Guys, what is this confusion matrix? Any idea? True positive, true negative, false positive, false negative. Have you heard specification and guys? Yeah. Shall I show you the PPT, or you know this? Do you have any idea about this confusion matrix? Accuracy, we are going to predict this one. Guys, please. So that I'll show you some PPT, so that I'll come back in the confusion matrix. Shall I show the one PPT that is small, 1 or 2, 3 slides are there? Shall I show you? What do you mean by confusion matrix? Do you have any idea? Yeah, 3 guys, please respond. Do you know what do you mean by confusion matrix? I'm asking about confusion.
Yeah.
Shall I show you?
It's like containing type 1 error and type 2 error, right?
Yes, type 1 error and a type 2 error. See, yeah. True positive, true negative, false positive, and false negative. Correct?
Yeah.
Type 1 error and type 2 error. Okay?
Yeah.
You are aware of these things, correct?
Yeah.
Okay.
Yes, that's correct, ma'am.
Yeah. You know this thing, confusion matrix, you have an idea. That is type 1 error and a type 2 error. Yes, exactly. Yeah. Okay. Like that is here we'll do directly. That is the confusion matrix. Okay. Now these are the two methods that I am going to importing from my sklearn. Okay. Now see here I am using again some set of arrays, that is np.arrange reshape is and array with some zeros and values. X, see, x is some arranging the 10 values. Y is, what is my y value is supposed to be zeros and ones. Yeah. Okay, now what is this x? This is my x value, and what is this y? This is my y value, that is arrays of, see, x I have taken 0 to 9, that is 10 values, y I have taken 0 and 1s. Okay, now what I will performing the model directly, I will go with the model. Solver is what? bilinear because I'm doing what? Binary, this one. Okay, random forest is what? That is the 0 because I'm not taking any random data here, just random state is a 0. Okay, very simple one I have considered, very simple one. X and Y value already I had taken. So what is this? Logistic regression. See, I'm calling directly model is equal to logistic regression. Solver is what? Bilinear. Fine. Next, what I'm doing? Random state is equal to 0 because I'm not doing any splitting for a timing. This is what happens. Okay. This is the run. Because, and just model fit, I'll check with model fit X and Y. See, logistic regression. See, what is the, when I say fit, what happens? These are the data it is to fit true, interpret scale, maximum iteration, how many iteration it has done, 100, class is warm, number of jobs, penalty, random state, solver is, all these variables it has been generated by this fit. Now here for this random, whatever the fit dot is there, that I am applying here. Now model dot class will give us the information that is zeros and 1. Okay, what is this intercept? Class is zeros and 1 because binary I'm doing. What is the intercept? I'll say intercept. This is the minus, that is your my beta naught. Let me check the coefficient. So model dot coefficient, say model dot coefficient, my coefficient value is 0.5. Now I will go with model prediction. Separately I'm running here. This is the probability value. Okay, and I'll predict with, that is model dot predict with X, and I'll compare X and Y value. That is the score is how much maximum score I have. Now what I'm doing, I'm performing the confusion matrix of Y, comma model dot predicted with the what I have predicted, what actually the X value, that is what the confusion matrix says. See here. Are you understanding? See, true, that is 1 1 is 3 and 0 0 is 6. That is this diagonal value 3 plus 6 is more compared to my false positive and a false negative, right?
Yeah.
Isn't it? See here. Yeah. Confusion matrix it is. Okay. This is true, correct?
Yeah. Yeah.
Huh? This is
false. Yeah.
This is false. This is true. This true negative, it is false negative. Am I right? So yep. This diagonal value 3 and 6 are more compared to my false value. So my confusion matrix accuracy is more. By seeing this confusion matrix, what I can say that is my accuracy is more because true values are more. Correct? Yeah. See, all this model, what I'll do, I'll put it into some, this confusion matrix, I'll put it into some graph, how it looks. Okay, see here. Confusion matrix of S, and I'll take grid, I'll take x-axis, y-axis values, and all these values, I'll put it into my graph. Look at this graph. See, this is the graph of my, say, actual zeros is how much? 3. Actual ones are what? 0. Actual, this is 1 and 6. This is the confusion matrix. I kept it in a form of a, what to say, graphical representation. Now, let me print classification report for my model, that what I have predicted for my X. This is what? See, precision, recall, F1 score, support, average, micro average, macro average, weight average, all these things automatically it has been generated by my classification report. See, F1 score increases means that my accuracy is more. Okay, my model accuracy 0.86, 0.92 with respect to my data, right?
Yeah.
Guys.
Yeah.
Huh? Here I have used what? Logistic regression. I build a model with model.fit. Then I took logistic regression. What is that? What type of logistic regression? I am doing binary. Then for each and whatever the model, I am calculating what type of class it is, arrays, because my both x and y's are arrays, and intercept, that is b naught, is how much I am calculating separately, and b1 I am calculating. Okay, I am adding this values for my model dot predict the probability with respect to x. These are the probability with respect to my x values. Okay, I'll try to predict model dot predict with respect to x. See, this is what the prediction, and score I am comparing, that is x axis, applying this score, how much I am getting, 90%. Then I am applying the confusion matrix. Confusion matrix is what? Here there is a type 1 and type 2 error are less because my true values are more compared to my false values. All these confusion matrix I have represented in simple what to say, graph format. Okay, when I say the classification report with respect to my model that has been predicted is this one here. This is the one. Separately, I have done all these things, guys. Okay.
Yeah.
Now, when I come to this, here. One more example I have taken. I have taken this, what to say, diabetic data set. Just now I have shared with you guys. Okay.
Okay. Yeah.
Now, what I did, I took a, see, these are the column names I have. That is, these are the number of columns that it is having. Whether the patient is diabetic or not, that I wanted to check. Okay, whether that is here, yes or no. Whether when I check the patient diabetic, yes, no diabetic means yes is, if the patient is not suffering from diabetic, the value is 0. This is what we try to predict. When a new patient is arrived, the model will say that is the person is suffering from diabetic or not. That is what here. These are the some parameters or columns we are going to taking. The person is having how much glucose, whether is a that she is pregnant, BP, skin type, insulin, BMI value, okay, so what is the age, all these things we are going to consider. This is there available in my data set that I have shared. Okay, I using the Panda and I'm taking all these things. See, read.csv file already I have uploaded in my repository. That is why I'm loading this data set. Okay.
Okay.
Now let me check this how the data looks like. This is what my data is there. Okay, what is this label? The label is my predictions. That is, sorry, output. Whether this she is pregnant, glucose level is this much, BP is this much, insulin so much. So labeled as a 1 means that she is suffering from what to say, diabetic. She's that some parameters. Based on all these parameters, we try to predict the output. Patient is suffering from diabetic or not. That is what label is there. Okay, guys.
Yeah, okay, ma'am.
Yeah. Now, what as I told you here, see, we have to split the features. That is for the we are splitting the data. Okay, considering all the amounts. See, and target variable, that is my target. Y is what? Label, and X is what? All this. Pregnant, insulin, BMI, age, glucose, BP, figure. This is all X values. What is my Y value? Y value is my label. That is my target value. Correct? Okay.
That's
After
correct,
this,
ma'am.
let me run this one. Yeah. To understand the model performance, what we'll do, we divide the data set into two. One is train and a set. That is what here I'll perform. From the scalar, this is what it is performing. I'm taking 75% and 25%.
Yeah.
Some error it is coming. Let me check why. 1 minute. Cross validation I have to include here. Just give me a 5 minutes time. Let me check this one. Okay.
Okay, ma'am.
Yeah, I'll take some 5 minutes time and then I'll check. Of cross validation, I have to use model selection function. Okay, guys, I am back.
Yeah, we can hear you.
Yeah.
Yep.
Okay, see what was the thing is instead of cross validation in my SQL learn, I supposed to consider the model selection. Okay, this was the error, that is why it was throwing in error message. Okay, import logistic regression model, create a logistic regression classifier object using this function called as. Already we have used this logistic regression, is that directly I'm using the function. See, linear model, I'm importing logistic regression. Okay, so this is the model. Logistic regression is what directly I'm calling this logistic regression function. For that I'm assigning my x value and y value. Correct? X value, what is the x is having? All these parameters I have. Y is having what? Label. Now I'll try to predict, that is the whether the patient is suffering from diabetic or not. Okay, this is the output is provided from this one. Now I'll predict with whom my test data. Now I'll perform confusion matrix with respect to this output. Look at here, this is the confusion matrix. And again, my positive, that is true values with respect to 1100, it is more. So obviously my accuracy of the model is good. Okay. Now all these values, let me put it into visualization. I'll see I'm using this NumPy, then I'm using MATLAB. Here I'm using one more what to say, library called it as a Seabird for making more beautification for my graph. Okay, this is what I have. See, entire classification I'll put for 0 and 1, subplot, class name, length I'll finding, then heat map I'm generating. I'll show you what is this heat map is. Okay, I'll come back again this explanation with respect to them. Just have a look at this graph so that, see, this is my actual label and a predicted variable. What is the range? Range is moving from this ledge. This is what position. See here, confusion matrix. See, positive is true is 119 and diagonal, see, 11 is how much? 36, 00 is 11. So false values are less. So my confusion matrix that we are represented in a form of a, this is called it as a heat map, guys. Look at here. Data frame, confusion, true, and what is your all these lessons we have with values, everything, configure labels, everything I have provided. This is what my confusion matrix that we have represented using a heat map. Okay, now let me check the accuracy. Look at here how I have find accuracy, then precision score, then what happens here, recall score. This is what accuracy, precision and recall. These are the, see how much accuracy my model is providing, 80%. Precision is how much? 76%. Recall is how many? That's a 0.5%. This is what I have my logistic regression, guys, with respect to my data set called it as what? Diabetic data set I have taken. Okay.
Yeah.
Yeah. This is the, yeah. See, this is very what to say, standard way. Here earlier first one what I had shown, simple. This is separately I'm calculating the coefficient and all. Now what I, in the second example, what I did, I took my one of the ready-made data set, that is a CSV5, even I had shared. These are the parameters are x value. Label is what? Prediction, that is the dependent variable. The label dependent on this value. So I have separated it. Okay. And y is my label. What I did, I have used directly the function, that is splitting my data 75% and 25%. 75% is in train, 25% is in the test data. So for that I am using this model selection From the model selection library, I am taking this method or a function called it as a train test split. Fine, guys. This is meant for what?
Yeah. I think so.
Splitting that.
Yes.
Yeah. I used logistic regression model. Okay, I directly called the logistic regression. For that, I have you give the x value and also y value. Then I try to predict with the test data. Then I have what to say, whatever I have prediction accuracy to check the matrix of the class. What I did, we have used the confusion matrix. Confusion matrix I have we have displayed in a form of a graph, that is a heat map. Once this is over, now I try to predict, I'll try to check the accuracy of my model. See, I use matrix dot accuracy score, precision score, and recall. So this is where, yes, none of the accuracy is 100%. Almost it is a good score, accuracy, and precision is also score. I can say this model is a better one and a best one. Fine. Guys, is it okay?
Yeah.
Yes.
Yeah. Now I'll take a lunch break for myself. In my this is here. Almost it is 1:30. Okay. Shall I take a